Welcome to our tutorial on how to plan high availability. My name is Wolfgang Christ. I'm business developer for power distribution systems. The secure electrical energy supply in buildings or industrial companies has become essential for modern society. Failures of individual components in the low voltage distribution can have costly consequences. In this tutorial, I will introduce to you selected measures that increase the availability of electrical equipment throughout the progress of a project, from the electrical planning and the installation towards operation phase. A single point of failure can have a significant influence on the possible consequences of a power failure and may trigger a disturbance from it. The time of interruption caused by the fault and the resulting consequences must be considered in the planning, implementation and usage of the energy distribution concept. The objective is therefore to primarily reduce the probability of failure. Nevertheless, statistically speaking, an error can occur at any time. The more individual components there are installed in the system, the higher is the probability of a failure for the overall system. Therefore, it is important to keep the interruption period as short as possible. Based on a classification of the Harvard Research Group, various gradations of availability have been established. There are no globally binding standards for supply reliability. Therefore, a decision-making method should be taken into account during the planning phase in order to consider the expected duration of a power breakdown after a disturbance. Besides conceptual measures, system technology measures have proven themselves. These measures are usually part of the planning phase for the decision about the required availability. The most proven and well-known means of ensuring the availability of technical equipment is redundancy. In the simplest case, redundancy means that another system is set aside which takes over its function if the primary system fails. With draw-out technology or modular systems, cost and space-intensive overcapacities can be reduced to an acceptable level. Sophisticated draw-out technology concepts promote availability through safe operation and fast interchangeability in the event of a malfunction. System-related measures such as manufacturing integrated arc fault protection or condition monitoring reduce the probability or impact of power breakdowns. If these measures are being taken into account during the planning phase, the additional costs are low. At the latest, with the commissioning and testing of electrical equipment, operational methods for the preservation of availability during operation and maintenance must be defined. In addition to operational safety, this also includes the obligation to plan and implement suitable occupational health and safety measures. Since a representative evaluation of end-user supply interruption is not available, an evaluation of published statistics from network operators serves as a basis. The published data for Germany by the Federal Network Agency from the year 2020 shall be considered as an example regarding the type of interruption. Additionally, the data has been selectively compared with the publication of the Federal Electricity Commission, known under ELCOM for Switzerland. Only downtimes greater than 3 minutes are being evaluated. The graph shows the ratio of planned and unplanned interruptions, as well as the number and total duration of unplanned interruption in hours. In comparison to the previous year, the average interruption time has decreased, but the total number of reported disturbances has increased. Almost 62,000 unplanned disturbances of more than 3 minutes duration were reported in the medium and low voltage grid was a total duration of almost 171,000 hours. Most power breakdowns were caused by operational cases or influences from third parties. Under operational causes, various errors such as short circuits and overload, but also material fatigue due to aging or incorrect operation are recorded. Influence of third parties include construction work damages caused by contact with machines, people, animals, but also vandalism. Other causes such as force majeure or extreme natural events, official orders, terror or interference from systems bear the least share. As you can see, unplanned interruptions are common. Using the example of supply interruptions of the network operators, the most common cases have been operational causes and influence from third parties. For example, the Federal Network Agency repeatedly mentioned unplanned supply interruptions lasting several days and weeks in the year 2020. In addition, natural influence are also relevant for end consumers. I have already mentioned conceptual measures and system technical measures as the most proven measures for reducing downtime as a result of malfunction. Both measures, if required, are already including during the planning phase regarding the decision on availability. Operational methods, on the other hand, are fundamental obligations for operational safety. They are also suitable for measures for preservation of availability during operation and maintenance. With the assembly, testing and commissioning, the project manager takes over the responsibility for the implementation of the electrical equipment. A consistent software solution supports the implementation from the requirements already specified during the planning phase for safe and reliable operation. The transparent and complete documentation supports the operator as well as the operating or service personnel in handling. Even after achieving service life, the documentation provides valuable information for replacement or disposal of parts. Further information on the planning and implementation of electrical equipment can be found on our website. There we offer you a variety of white papers, webinars, references and much more. My colleagues and I are looking forward to receiving your inquiry.